We are trying to solve a problem in surface tension. The problem is given like this. A wire frame ABCD, let me just read out a problem for you. A wire frame ABCD slide with a sliding wire EF of length 20 centimeter is placed vertically. Let me draw a diagram up to that and show you first what do you mean by that, right? So there is a wire frame like this. Frame named is something like ABCD. Wire with a sliding wire. So if you call this name as something like ABCD, this name is not that big important for us. This part is important with a sliding wire of EF. So assume this is what my sliding wire is. I'm naming that sliding wire as a test one, right? Yeah, this is the sliding wire. So this is what we mean by sliding wire given in the problem. Length of the sliding wire, that is EF length, is given for you as 20 centimeters, right? It is placed vertically just like this. It is placed vertically. When a thin film is formed in BCEF, right? So you can imagine this part is not free now. It's filled with some kind of a liquid film like a soap film. So what I have filled with a pink is a thin film. This is what I mean by a thin film. A thin film of the liquid will always show the property of the surface tension. That thin film will try to pull, because of the surface tension property, it will try to pull the film walls, that is walls of that frame, towards the center. Therefore they can acquire a minimum surface area. But what all I have shown, these things like this force, this force, this force, this force, doesn't materializes and able to pull the film because they're all fixed. That's what's very important thing, right? These are all fixed film walls. Therefore, they are not going to move. That means the force on that part of the walls due to the surface tension doesn't place any role because they are the solid surfaces. They are not able to pull. But look at this part, lower part. It is, he said it is a sliding one. So it is movable. So this sliding wire is being pulled upward and it moves because of the surface tension force, so that that film acquires a minimum surface area as per the property of a surface tension. Liquids always tries to acquire minimum surface area. So that pulls it up. That pulls it up with how much of a force that can be identified based on the definition of a surface tension. What's the definition of a surface tension? That's the force acting per unit length. But we have to take the entire length, that is free length, that is in contact with the wire, movable wire, right? So this wire, which is a thin wire, has its inner part as well as the outer part, because the wire is thin, are both are connected with the film. Therefore, the length actually becomes two into L. So one L is the inner length of the wire, the other L is the outer length of the wire, and both are connected to that. So how much force is acting to minimize the surface area is T into 2L. This is the force with which it's acting upward, right? So what's our question is, let's go back to your question now. Okay. The mass of the block that has to be suspended from EF in order to keep the equilibrium. Means what's trying to do? Here he want to suspend a mass, M. What this M will do? It will apply a force mg in a downward direction. He want to keep this wire in equilibrium. If we have to keep any body in equilibrium, resultant force acting on it shall be zero. So the force acting on the wire in upward direction to minimize the film is T into 2L. The force acting in the downward direction must be the weight of the wire that is suspended. And to get an equilibrium, for equilibrium, what has to happen? Force upward shall be balanced by the force downward. What is that force upward? T into 2L. Why I have taken 2L? In spite of the length of that part of the wire, movable wires, sliding wire is only L because its inner length as well as the outer length are both connected with the soap file. So T into 2L is equal to mg. We want to calculate that m value. So m value will be T into 2L by G. All the values are given for us in the problem, right? Let us substitute the data and get an answer, right? I'm just sliding it up so that I can make a room for further writing the data, further solving the problem. Yeah, that implies M that need to be suspended is, yes, T. What's the value of the T given for us in the problem? Look at the data. Surface tension of the problem is, of the liquid is given for you as 40 into, yeah, just a sec. It is given as 40 into 10 power minus 3 Newton per meter. So I can write that data, yes, in place of T. 40 into 10 power minus 3 is an SI system. I need not make any conversion. Into 2 into L. L is given like 20 centimeters. That is 0.2 meters. G is given, if you observe little carefully, as 10 meter per second square in SI system. That is 10. I need not make any conversion. That is 4. 4 into 2 is 80. 80. Sorry, 4 into 2 is 8. 10 power minus 3. The 0.2 is 2 into 10 power minus 1. So 8 into 2 is 16 into 10 power minus 4 kilogram. That's the answer that we have, 16 into 10 power minus 4. But that option is not there. Look at this option. It is given in terms of 10 power minus 5. Of course, all these are obviously wrong. But the answer is given in terms of 160. So let me just convert that into 160 by multiplying with 10 and by dividing with one more 10. That becomes 10 power minus 5 kilogram. So how much of the weight that I need to suspend in the downward direction is this much. So the surface tension force is being balanced. So I want you to understand that the surface tension force is very small. That's why you will be never able to walk on the surface of the water like a small ant is able to do, because the weight or the mass of the ant is small such that that's able to be balanced by surface tension. But we are very huge to be balanced by the surface tension force. That's why we automatically sink into the water if you don't swim. Don't depend on surface tension force, assuming that that will help you to float, right? It's not a surface tension force. There is buoyancy, of course, that makes your weight less. That's altogether a different subject. But surface tension force is a small force that's able to work in only small way. Thank you for watching.